Hello, PLP geometry. Welcome to the 8th and final lesson in Unit 4. We've made it, right? So, we went through our similarity. And now we're going to enter our last video talking about right triangles. This is very much a piggyback off of trigonometry. So video number 8 is titled Angles of Elevation and Depression. Angles of elevation and depression. Okay, so let's talk about these two types of angles in terms of, building them, and then we'll do a couple word problems as examples. All right, so first of all, let's talk about our angle of elevation. So the angle of elevation. So when we have an angle of elevation, right? So when you think of elevation or elevator, think of going up, right? So an angle of elevation is built by a horizontal. Typically, it's the ground. It could be someone's line of like eye level, right? But typically it's the ground. So this is my horizontal. And a line of sight to some object in the air. So say there's some object right here. I'll just put a star. So and this segment called the line of sight. The line of sight. This space right in here, I'll use a different color. This space right here. This is where the angle of elevation is, that angle right there. Now notice if I drop a vertical from this object down to the ground, I create a right triangle. And angles of elevation and depression are right triangle applications. So again, we will use trigonometry to solve something about this word problem. Okay. If we take a look at the angle of depression, angle of depression. So if you think of depression, right, we're down, we're blue. So in this case, right, we have some sort of an object. And from this object, we have a horizontal in the air. And there might be some other objects somewhere on the ground. So if this is the ground, right, there's some other objects down here. And we have this line of sight. Line of sight going to that object on the ground. This space right here, created by the horizontal and the line of sight, this is where the angle of depression is. Okay. Now, for this picture, again, if you go up from your object on the ground, if I go up, there's my right angle, and there's my right triangle kind of up in the air. So it's a little bit, I would say, a little bit more abstract than the angle of elevation problem. Now, if you put these two ideas together, right, both of these angles are formed by horizontals. So there's a ground horizontal, and there's an in the air horizontal. Those two horizontals are going to be parallel. And then you have this transversal running through, acting as the line of sight, right? Let's do it this way. There's your transversal. Down here, I'll put it in a color. This is where your angle of elevation is created, right here. Up here is where your angle of depression is created, right there. If you remember from Unit 2, Unit 1 and Unit 2, if I asked you what letter do you see, I hope you would see the Z, right? The angle of elevation and angle of depression are alternate interior angles. So in any problem, if they give you elevation or depression, you can use the other one if you feel more comfortable doing that. Because since the horizontals are congruent, your angle of elevation is congruent to the angle of depression. So it could be a useful fact. Okay, so we're going to do two problems directly from Delta Math. So here is the first one. I'll write right on there. Okay. So it says, from the observation deck of a skyscraper, uh, Valeria measures a 67-degree angle of depression to a ship in the harbor below. If the observation deck is 945 feet high, what is the horizontal distance from the base of the skyscraper out to the ship? Okay, so I will be giving you the pictures, but since I'm with you, I'm going to lead you through. We're going to draw our picture right over here. Okay, so what I first need is I need this skyscraper, right, where Valeria is in. So she's up here in this building. Okay. And she sees a ship out in the harbor. So again, there must be road and then water. Here's this ship. Okay, that's my boat. So it says that there's a 67-degree angle of depression. So again, I see angle of depression. That is formed. So again, let's put Valeria here. That is formed by a horizontal going from Valeria and a line of sight going to the ship. This angle right there is my 67-degree angle. Okay. Now, it says if the observation deck is 945 feet high, so I know that this right here, this vertical height, is 945 feet. Okay. What is the horizontal distance from the base of the skyscraper out to the ship? So they want this distance right here. Okay, we could call that X. So what I think would be smart, right, is I think that we should, again, use this bottom triangle right here. I think that this is a right angle where the skyscraper hits the ground. I know that my angle of depression and elevation are congruent. So if that's 67, so is this. And now I have a right triangle. I have an angle measure. I have a side length. We can use trig to find the other side. So right now, so katoa. So, okay, 67 is my angle. I'm going to put an arc there. It is pointing to the 945. This is my opposite side. This orange line of sight, this is my hypotenuse. And then X, we're going to find, that's our adjacent. Okay, if I look at the three sides, the one I don't care about is the hypotenuse. So I'll cross off H, I'll cross off H. This is a tangent problem. Okay, so to do this problem, let's set it up. So tangent of my angle, 67 degrees, equals, and it's opposite over adjacent. The opposite side is 945. The adjacent is X. Okay, and now we're trying to find X. So we start this problem off by multiplying both sides by the denominator, which is X. That'll give us X times the tangent of 67 degrees equals 945. The X's will cancel. Notice X is not by itself. It's being multiplied with the tangent of 67. So we're going to divide both sides by the tangent of 67 degrees. They will cancel. X will be by itself. And this is what we're going to type into Desmos, that division problem. 945 divided by the tangent of 67. Again, make sure you're in degrees still. I am. 945 divided by the tangent of 67. And let's assume it said round, well, let's say, what's it say? Round to the nearest hundredth, right? So that's 2 decimals, right? So if I look at this problem, so X would be 401.128. So again, hundredth. So this is the hundredth place. That 8 is going to round the 2 up to a 3. So our horizontal distance is 401.13 feet. And there we go. Okay, so that was us finding a side length. Let's do one more where I help you guys find an angle measure. Okay, so let's try this one. So it says Justin wants to use a sheet of fiberboard 33 inches long to create a skateboard ramp with a height of 14.5 inches at its highest end. Find the angle of elevation made by the ramp with the ground. Round your answer to the nearest tenth of a degree. Okay, so let's take a look at this. And again, you'll be given a picture here. I'm going to give it, I'm going to help you with the picture. So I see angle of elevation. So I know that means I have a ground and I have a line of sight. Now, this case, our line of sight is the skateboard ramp. So I'm going to make it solid. And then I'm going to drop it down. So this will be the highest point of this ramp. Okay, this angle right here is my angle of elevation. That's what I'm trying to find. So there's my X. Okay, so that's the angle of elevation part. It says that he wants to use a sheet of fiberboard 33 inches long to create the ramp. That means that the physical ramp, that is this side right here, that is going to be 33 inches long. The height of the ramp is 14.5 at its highest end. Height, whenever you see height, that's the vertical. Sorry. 14.5 inches. Well, let me put the inches there, sorry. Okay, so now, if I look at this picture, right, I think I have the right angle right here, where the height of the ramp meets the ground, right? Okay, so this is a trig problem. Again, notice they give me two sides. So X is an angle. X is an angle. So that immediately means I'm going to have to use an inverse. So I'm going to set up my problem just like normal, but I'm going to use an inverse to solve this problem. Okay? All right, so let's get a little darker color here. We'll go back to blue. Okay, so X is my angle. I'll put my arc, draw my arrow. That means the 14.5 is my opposite side. The 33 is my hypotenuse. This side down here is my adjacent. Again, we're doing SOHCAHTOA. I'll put it right here. SOHCAHTOA. I do not need the adjacent. I don't care about it. They don't give it to me. So cross off ka, cross off toa. This is a sine problem. Sine of my angle. Now my angle is x degrees equals opposite is 14.5 over hypotenuse, which is 33. Again, it would not make sense to multiply by the denominator. So this is where I'm going to take both sides and I'm going to apply the inverse sine to both sides. What that does is that cancels out the x, the sine to make x, and then over here we're just going to take the inverse sine of 14.5 over 33. And this is what we'll type into Desmos, and it says round to the nearest tenth of a degree. So let's do that now. So I have sine raised to the -1 of 14.5 divided by 33. And I get 26.06. So my angle measure is 26.06. The 0 is in the 10th spot. That 6 will round the 0 up to a 1. So my angle measure is 26.1 degrees, and that should be the angle of elevation with my ramp. Okay, so this assignment is a worksheet. Again, we have a couple problems that you have to work on, finding angles of elevation or using trig to find a side length using angles of elevation or depression. All right, best of luck.